Hello everyone, welcome back. I'll just quickly recall in the last class what are the things we had covered. So we started with, as I told you, I am going to see the two different type of crypto system here. One is substitution, another is transposition. What happens in the case of substitution? Substitution means what? I am going to replace the every character by another character, another alphabet or character, correct? And there was two things which I had focused. If one character is replaced by unique character, then it is monoalphabetic cipher. If one character is replaced by another more than one character, then it is called polyalphabetic cipher. The first one was shift cipher, whereas the encryption was x plus key modulo 26. A fine cipher where the key space was the tuple ab, and encryption was ax plus b modulo 26. Substitution cipher, yeah, it is just example which I has given, that I'll be given a table that each plain text abcd, it will be replaced by some another character. It may not belongs to the same. See, that's why I'm going to call it as substitution cipher. It is the standard one. All the previous one can be written like this, because see, the plain text say k is replaced by exclamation mark, z is replaced by some new notation. So I'm just putting a table for you which you have to follow and encrypt your message. So that's why it is called substitution cipher. Then Wigner cipher, yeah, after these three ciphers which I have told, these are monoalphabetic cipher. That means every character is replaced by unique character. But whereas in the case of Wigner cipher, what is happening? Look at this. If I'm having hello world, see, suppose H is inside or somewhere, see O was here, and look at this O. So the position may for the key position may be changed. So this O will be replaced by something say K, and this O will be replaced by something say A. So the single character is replaced by different values. So that's why it is polyalphabetic cipher. Whereas in this case, your plaintext cipher takes key space are the tuple of m element belonging to z26, and just encryption was I just have to encrypt. I just have to add key to the each element, that is x1 to plus k1, x2 k2, and so on. This was the encryption. Decryption, it is similar to your shift cipher, but here I am having m tuple. In the case of Hill cipher, your key space is set of all invertible matrices. So suppose I am having M, then encryption is just multiply your plain text with the matrix M. See, again also here the block, I am dividing my plain text into block of size M and then encrypting it. And decryption, I'll just multiply with M inverse. So as I told you, in all the crypto system discussed above, a character of a plain text is substituted by another character which may not look like your plain text. Okay. Now let us see, next is transposition cipher. Transposition cipher. So in this cipher, the alphabets or characters of a given message, or plain text are permuted to obtain the ciphertext. Permuted to obtain the ciphertext. That means I'm not going to replace or substitute by another character. I'm just going to permute. So that's why this cipher is also called permutation cipher. See, the idea of permutation cipher is to keep the plain text character unchanged, but effect a change in their position using some permutation. So if you see, let us take an example of the permutation cipher. Suppose my P and C is this Z26 raised to M, and K is, I am having all permutations, permutation mapping, say pi from this set 1 2 up to M, 2 1 2 up to M. So let me start. Let X is the plain text, so let X is equal to say x1 x2 up to xm. This is my plain text. The encryption is given by, yeah, my key is a permutation pi, so encryption, so e pi of x1 x2 up to xm, it is given by x pi 1 x pi 2. That means I am just changing the position, x pi m. Okay, so for the decryption I have just have to take pi inverse. This d pi of, say, yeah, the value after, yeah, modulo 26. I actually here no need to do any modulo, because just I am not taking any addition subtraction, I am just interchanging the positions. So whatever I will get, I'll be having y1 y2 ym. For decryption, y1 y2 ym, what I'm going to do, I'm going to y pi inverse of 1, y pi inverse of 2, and so on up to y pi inverse of m. This is how I am going to decrypt. Okay, let me take a simple example. Suppose pi is equal to 1 2 3 and say 2 3 1. This is what your pi. So what is pi inverse? Pi inverse means what? Write this 1 2 3 on the top, 1 2 3. What do you observe? 1 goes to 3, 2 goes to 1, and this 3 goes to 2. So this is what my pi inverse. I got pi inverse. What I have to do, suppose I would like to encrypt a message m. Suppose my message is hello, or hell. Hell is my message. So what is the encryption? So actually, sorry, I'll write like this, hell. What is the encryption? Encryption of x is going to be, I have to change the position. Look at the first guy, h. The position of first guy, it is going to be, see, 1 goes to 2. First guy should go to 2. So this this is now second term, h. Second goes to third, so e will be here, and last guy will come here. 1 goes to 2, 2 goes to 3, 3 goes to 1. So this is what my encryption is. I'm just, see, again, observe one thing, my characters are same, I'm just interchanging their position. For decryption, I just again have to take the inverse. 1 goes to 3, the first variable will go to last, so L will be at the last. Second goes to 1, second variable should be on the first, third variable should be on second. So I got my plain text if I apply the decryption. Correct? Yeah. Even actually your permutation cipher is the special case of Hill cipher. Permutation cipher is special case of Hill cipher, because every permutation can be written as a matrix. correct? So you can write the permutation Kij as 1 if I is equal to pi of j and it is 0 otherwise. So you will able to write the permutation matrix. So for the example, I suppose my permutation was this 1 2 3 2 3 1. So I can write a matrix for this. The matrix will be this one. So look at this. If I is equal to I is Kij, so I'm having 1 1, it will be 0, it will be 0 because 1 goes to 2. So at position 1 2 I'll be having 1. Next 2 3 at position 2 3, second row third column, I'll be having uh, did I write the inverse of this? Yeah, see j pi of j should be I. So I'm actually writing the inverse of this. So 2 3 means 3 2, third row, second column. So here it should be 1. And then 3 1 means 1 3. That is done. 1 2 means 2 1. So here it should be 1. So this is my matrix. This is my permutation. You can find inverse of it. Inverse will be inverse permutation. So you have to just take the pi inverse and try to apply this technique and get the matrix. With this technique, from any permutation I am able to change as the matrix. Okay, now let us see some more example. Next is Scytale. So this is the first example of transposition cipher. We'll change the color first. Scytale. What is Scytale? Scytale is one of the oldest crypto system. This technique was popularly used by Spartans for confidential political and defense communication. In this method, the sender and receiver both passes a cylindrical called, they both, suppose I am having sender here, receiver here, he has a cylindrical structure. The same cylindrical structure is there with this guy also. Okay, so suppose he want to send something to him. So what he is going to do, the sender uses a wound on the narrow, so he is going to wound a narrow strip around it. So there will be a mark here. From here he have to start and here have to end. He will wound and he'll write on it. So try to observe it as wound. I am not able to draw it properly, but so he'll write his message, hello, welcome, like this, whatever attack is going to happen somewhere. So after that he will take out this ribbon. If he take out this ribbon, what do you observe? The characters are not in the same format. It is something else that will be seen. This is your actually ciphertext. So if you are not having this cylindrical fall, that is called Scytale, if you're not having this cylinder, you won't able to get the plain text. And here observe that the plain text characters are same. I am just changing the position. So if you have this, you cannot get the value whatever it was written in Scytale. Correct. Now if the receiver got this, what he is going to do, he is going to mount it on the Scytale. The same format, there will be a mark, and then he would able to read the message very clearly. This is what your Scytale technique is. So it actually depends on the circumference. If the circumference of the cylinder is C unit, then the idea of Scytale is to write the plain text into C rows with fixed symbol in each row and then read it by column to get the ciphertext. You have to read it by column. You write it like this or like this. If you are writing as a row wise, then you read it as a column, or it will, after removing, you will already get a ciphertext. That is one way. One more is rail fence. Hmm. The rail fence cipher. What is rail fence cipher? Here the characters are, this is also called zigzag cipher. So it is again a form of transposition cipher. It derives its name from a way in which it is encoded. So suppose you want to, your message is attack. This is the message which you are to send. So how will you write? You write like this: A T T A C K. So what is your ciphertext? Ciphertext is read it like this: A T C T A K. So your plain text was this, your ciphertext is what I have written. Actually, I have written zigzag. It is something like rail track. That's why it is called rail fence. I have written my message like this: A T, and then T here, then A here, then I again. This is how I wrote my message, and then by row wise I have written the ciphertext. That's why it is called rail fence cipher. Okay, this was all about block cipher. So crypto system with this principle are called block cipher. We'll be seeing in more detail in the later. And the next cipher is called stream cipher, which I had told you while classifying. There are two type of ciphers. Classical cipher. I started with block cipher. Now in the next class we will start with stream cipher. Thank you so much.